This video will take a look at the speed by thickness, edge length, and material selections when you're in the bevel cut area of the 3D 5X. These selections can be used to optimize your speed on different types of cuts. Let's go ahead and we'll create a part out of this. And we'll just use our bevel 2D and we'll put some 45-degree bevels on here. This is 1-inch thick material. I'll hold my control key down and do that. Enter and close. And now we'll go into bevel cut. And we'll start off with speed by thickness. And I'm going to use the plus button so I can choose what surface I want to do first here for this demonstration. Left click there for the start point, enter for end point, direction will go that way, left click, and we'll left click on these surfaces to do the bevel cut first. Because I have speed by thickness selected, these yellow lines go all the way down to the bottom of the part or the top of the table, and the speed is calculated based on the length of these lines. Speed by thickness looks at the angle of the bevel cut and calculates the total thickness of material that the stream is going through. Because this is 1-inch thick material and the bevel angle is 45 degrees, it's going to calculate that it's cutting through 1.414 inches of material, and it'll give us speeds based on that measurement. Next one, speed by edge length. Left click, enter, left click, enter, and done. Because this was speed by edge length, now these yellow lines only go to this edge here on this cut. Because this bevel cut's going halfway down through the material, these will be 0.707 inches long, and our feed rates will be based on that thickness. And finally, speed by material. And done. If we can measure these yellow lines, we'd see that they're 1 inch long, and our feed rate will be based on material 1 inch thick. If you are doing a countersink like this, you can use these selections to optimize your speed. You'd probably cut the vertical cut first, and on that one you'd use speed by thickness because you're cutting through the entire thickness of the material. But then when you come back and do the countersink, you could switch by speed by edge length. Since you've already cut away the vertical surface, you're only cutting through that portion of the material, and you'll cut that faster than if you did the countersink at the speed by thickness selection. Let's go take a look at some numbers. Taken some screenshots of those different values with the speed by thickness at the 45 degrees and 1 inch thick. Again, we're cutting through material 1.414 inches thick. We should see a speed of around 4.67 inches per minute. Speed by edge length, it's going to be half of that. That'll be 0.707 thick. We should be cutting at about 10.37 inches per minute. And then speed by material, because we've selected 1 inch thick material, it'll do that cut at 6.96 inches per minute. Let's see if that's actually what we get. So here in the first cut, speed by thickness, we max out at the 4.67 inches per minute. And then on the next one, speed by edge length, we're doing that 10.37 inches per minute. And then speed by material is the 6.96 inches per minute. If you have any questions on that, let me know. Thanks.